Let's graph a log. So as I look at this problem, I have a few things going on. I have log base 4 of x, and it's been transformed in two ways. So I have log base 4 of x, and I have two transformations. I go left 2, and I go up 4. The way we've been approaching this is that I start by creating a table for the parent function, y equals log base 4 of x. Now, that's not quite as simple as it seems. We don't really like logarithm form. It's a little bit more complicated. So when we make our table, we actually convert this to exponential form first. I can rewrite log base 4 of x equals y as 4 to the y power equals x. And when I substitute in for a log, because it's the inverse of an exponential function, I can kind of work backwards. I can treat this as an exponential function, but y's come first and x's come second. So what I'm going to do is I'm going to plug into my y column -2, -1, 0, 1, and 2. And in my x column, I'm going to evaluate these functions. So 4 to the -2 is 1/16. 4 to the -1 is 1 over 4. 4 to the 0 is 1. 4 to the 1 is 4, and 4 to the second is 16. Now this is not my function I'm going to graph. This is effectively my parent function. This function has been changed in two ways. I have moved it left 2 units, which will affect the x values, and I've moved it up 4 units, which will affect the y values. Think about what happens when I move to the left on a graph. My x values become increasingly negative. In other words, if I want to account for that leftward shift, I need to subtract from my x values here. Specifically, I'm going to subtract 2 from each x. This can be tricky. Let's start with something a little bit easier. So I will start at the bottom. 16 minus 2 is 14. 4 minus 2 is 2. 1 minus 2 is -1. 1/4 is minus 4. Minus 2 is -1.75. And 1/16 minus 2 is -1.9375. Those are my x values. Now I got to deal with my y values. What's happened to my y values? Well, they've moved up 4 units. In other words, I need to add 4 to each of my y values. -2 plus 4 is +2. -1 plus 4 is +3, 4, 5, and 6. Those are my points. Those are the points I'm going to graph here. -1.9375. I don't know exactly where that's going to fall on my graph, but it's going to be really close to -2. Let's zoom in and see what we can do here. So somewhere close to -2 and +2. There's a point there. -1.75 and 3 should look something like that. -1 and 4 would go there. 2 and 5 would go there. And 14 and 6 would be somewhere off our graph in this direction out here. What my graph should end up looking like this. It's going to be curved up in this direction. Obviously, I didn't do a perfect job as I created this. One thing to point out, we will have what's called an asymptote. It's a line that our graph approaches but never crosses. In this case, our asymptote is at x equals -2. Our graph will get closer and closer to -2, but will never cross. And while we're talking about asymptotes, we should talk about domain and range. On this graph, my domain depends on my shift. The domain of any logarithmic parent function is is greater than 0. I've moved my function 2 units to the left, so my domain here is x is greater than -2. And my range for any logarithms is all real numbers.